Okay, we're recording now. Anybody cares to share the screen? Okay. Go ahead.
Is it showing والله?
Yeah, it is showing. I can see you're starting the assignment one. Ibrahim, go. You need to start your quiz. Start a quiz at the bottom. Yes. It's not a quiz. It's an assignment.
ما درست شلونها؟
أنا ما درست إبراهيم كمل.
Yeah, Ibrahim.
هلا.
This is an assignment, and this assignment is an exercise.
يعني
Okay.
نحلها معاك أستاذ.
Well, yes, but it is set up so that everyone will have different values as an exercise on how to use the sinusoidal functions. You can do this test as many times as you want until the due date, and only the highest grade will be kept. So don't worry if you didn't do well in the first instance. So now it's saying a sine wave has an amplitude of 130 amps, frequency of 60 hertz, lagging phase angle of 60 degrees. Compute the magnitude of the signal at time 0.024. Hussam, did you do the plots as well with us, or you didn't catch up?
I did catch up, but I didn't get them. I need to study it.
Okay. All right. So, are you able to do this, Hussam, or not yet?
Not yet. I need help.
Okay. Now let me show the work that we did earlier.
Should I stop sharing?
Yeah, you can, or I can stop you as well. I'll just open what we did this morning.
Mr. Hafuda.
Yeah.
Before I forget, just at the end of the class, can we discuss about moving up the session to after the lecture?
You mean change schedule?
Yeah, that way it'll be 2 hours consistent, and then we.
Yeah, Saad, and this is for everyone. Changing of schedule is not up to the instructor; it's up to the chair, the program.
Yeah, that's what I'm asking right now.
Yeah, I already asked for some changes, and they have a lot of things to do with the schedules.
I mean, if we decide together and everybody's free in that time slot, then we can just do it.
Absolutely, I would support that for sure. As long as it doesn't interfere with anybody's schedule, it doesn't interfere with mine, and the chair agrees with it, for sure, go ahead.
All right.
Yeah, absolutely. That's what we're here for. All right, so I'm going to share my screen. This is what we did this morning, Ibrahim. Very simple plot of one single sine wave. And basically, this is the general equation for sinusoidal functions. And then we did a little more. We created two waves. Now, instead of using here, we're just using simple angles from 0 to 360 degrees. Whereas here, we're using omega t instead of angles. Okay. And then we're also including phase angle. So this is the very general format for a wave. This is the amplitude, the peak. This is the peak. Guys, everyone got the notebook? Are you taking notes? I mean, it's all okay. I will put the recording again. This recording, I'll put it also on D2L. But if you're just going to be repeating the video, it probably will not catch up as well as if you capture now. So what I'm saying is that it's important to know that usually in these plots, we're interested in the peaks. But these formulas, or later on, we can be also talking about RMS values. But here we're talking about the actual instantaneous values. Okay, so here we have a phase angle. And this morning I showed if the angle is positive, it's leading, meaning the curve moves backwards. If the angle is negative, like minus 30, the wave moves forward, which is lagging. So a negative angle is lagging, positive angle is leading. So now with this one, I can put any phase angle. And I can see that my second signal, which incorporates phase angle, changes. This is like my reference. Okay, now, therefore, this is what you have. If I give you amplitude and give you frequency and phase angle, you should be able to find the instantaneous value at any time, because these are time values that we selected this morning. But you can plug in any time value. So here, the question that we saw with Sam, of course, again, it's different from person to person. So let's do this together. Sine wave has an amplitude of 220 amps, frequency of 50 hertz, lagging phase angle of 90 degrees. Compute the magnitude of the signal at time 0.092 seconds. Then use Excel to plot it. What should the value be? You can use Excel for this as well.
We can use Excel, or we can use a formula.
You can what formula?
The V sine omega t, that formula.
Yeah. Exactly. So go ahead and do it. And then plug in the numbers. The marking here will be automatic when you submit. When you submit this. Yes.
Where can I find the formula?
I showed you the formula just now, yeah, Ibrahim. I'm showing you again.
لا بس الحين في الديتويل وين ألقاها؟
No, there's no formula in D12. You have to use your calculator or use Excel.
إيه بس الفورمولا وين؟
And formula in front of you right now. Do you see my screen? This formula. The amplitude times the sine. Make sure your calculator is set to radians. Excel defaults to radians. Excel defaults to radians. So you don't have to change anything in Excel. So let's do it. What's the amplitude?
Garage?
What's that? Hello? Did someone come in? What happened? Are you with me, guys? Hello?
Yes,
Yes,
sir.
yeah, we are with you.
Yes, sir.
Okay, so frequency and then phase angle. What's the amplitude we said? Amplitude was 220 amps. So 220. Frequency, 50 hertz. It is amps. And phase angle. Phase angle, he says, 90 degrees. 90 degrees. All right. And time value. What I want to compute is 0.092 seconds. Yes. Okay. What's my value?
Sir,
Yep.
it says in your question, it says lagging phase angle of 90. So
Yes.
are we going to use 90 or are we going to use a negative 90?
Plus 90. Remember, lagging is
Yeah, plus.
plus.
Yeah, plus. Plus.
No. Wait. Plus is leading. Negative is lagging.
Right.
Because negative moves the waveform forward, which is later in time. Plus moves the waveform backwards, which is earlier in time.
Mm-hmm.
Clear? Right? Okay, now let's do it. Equals to the amplitude times the sine. Well, here, remember, it's a good idea to compute omega. Omega is equal to what? 2 pi F. That's your omega, radians per second. Are you with me? Ibrahim?
معاك سو بس مو فاهم ولا شيء بس مو
No, but
مشكلة.
you know, but this is old stuff. Omega is what? Angular frequency, right?
صح.
What's omega? Omega equal to what, ya Ibrahim? 2 pi f.
اوكي.
2 pi f. That's what we're doing here. We're just saying two. In Excel, pi is written as this. Pi open close parenthesis. Right, Abdullah Noor?
Yeah, I'm writing.
Okay. Now, if I hit enter, I will see the value of pi. So here, all I'm doing is 2 pi times the frequency. Frequency is right here. So I can change the frequency, and then pi will, omega will change as well. That's the power of formulas in Excel. Has everyone got, this is pi. I can call this pi equals, just bring this down. There's your pi, just for clarity. Okay, now I'm just doing what is my general formula? My general formula is A sine omega t plus phase angle in radians. That's the general equation, Ibrahim. I'm going to make it big.
تمام.
Clear? So now all I'm doing here is a formula. All formulas or formulae in Excel, they start with equal. They start with equal. So now I'm going to point to where the amplitude is. And then times sine of omega, which is this, times my time value, that's omega t, plus the phase angle in radians. Or I can do something else here. I can also make it equals, how do I change from degrees to radians? Multiply by, aywa?
Pi divided by 180.
Divide by 180. So now this one is radians. Are you okay with, is everyone okay with me?
Can you just repeat this part, sir?
All I'm doing here is I'm just multiplying this, changing this from degrees to radians. How do you change degrees to radians? Multiply by pi.
Okay. Okay.
And then divide by 180.
By 180.
Yes. And the opposite, if you want to go from radians to degrees, you multiply by 180 and divide by pi. All right, so now let's go and do the equation again. Equals the amplitude times sine of my omega times t. So omega t plus the phase angle in radians. Close parenthesis, enter. There's my value. Minus 178. So you go to, here you go, minus 178. What are the units?
Oh, amps.
Amps. A for amps, V for volts. Now, of course, you need to plot it as well. Okay, go ahead and do this one now. It should be very easy. All you're changing is just the amplitude. Frequency is basically the same. It's also 90 degrees. Phase angle. Compute the magnitude at 0.022.
Sir, but it's lagging this time, not leading.
It is the S. No.
It's
This
leading.
is, this
It's
one
No,
is,
it's leading. I mean, yeah.
this is leading.
Yes, yes.
No, this is leading, so it's plus. This will be negative.
Yeah, this would be negative.
So this will be negative. So then this one This one should be minus.
Yeah, so we should account for the negative value as well because it's lagging, right?
Yep. Or we can leave this formula as it is, and instead we'll just put this as minus.
Yeah, yes.
Minus 90. So
Right.
it becomes 178 instead of minus 178. It becomes 178. Okay? Go ahead and try it. If you have any problem, show me your screen, and then I'll walk you through it.
So the final output is our final answer for the question.
For these values, your sound, your audio is not clear, Saad.
I was saying, so for the question, the final answer would be the output.
Yeah, 170. It should be 178 for these values.
Okay.
Sir
Everyone
Hafuda,
okay?
when you say use Excel, plot the function and submit your work.
Yes.
So you want us to plot the points, all the points, and show you the sine wave?
Oh, absolutely, yes. Absolutely. Now, of course, I want you to think about, instead of me giving you all the answers, I want you to think about how many points you need. Right? Remember, for a good sine wave, you need at least 8 points in one cycle. So you have to figure out your steps. So here, the period again is 20 milliseconds. So you divide that by 8, or you can divide it even by 10. Even 10 should be, but if you want to capture the peaks and the troughs, you know, it's always a multiple of 2. Like either 4 will actually give you a triangular wave. But if you have 8, or you have 16, or if you have 12, rather than 10, you will capture the peaks and the troughs. But again, the more points you have, the more accurate the sine wave will be.
So it's preference.
Muhammad?
Yes.
It's preference.
Sorry?
So is it preference? Can we choose 8 or 10 or 16?
Minimum is 8. Minimum. If you increase more than 8, then that's your choice. But minimum, I mean, it will not change the characteristics of the wave in terms of frequency and amplitude and phase angle. It will just make it more accurate. But usually 8 is a good approximation of the waveform. Yes, Brahim. Okay, now I've got some people who just joined in. Now I've got 8.
Sir?
Yes, sir.
Can you just press, click on 178, the output? I just want to have a quick look.
The function, you mean?
G6.
What do you need to look at?
Cool. False. Okay. Yeah, I just wanted to look at the formula.
The function?
Yeah, the minus 157.
It's not minus. We changed this to minus 90 because it says lagging.
Yeah.
So
But it's weird. I'm getting different answers though.
Why is that? Everyone is getting the same answer, or
different values?
What's that? Oh, yeah, of course. If you have different values, you get different answers.
No, I did use your values, sir.
You use these values.
Yeah, I used these values.
Okay, then you need to show.
I missed something.
Okay, you want to check, or you want it to check for you?
Just can you press on click on the output? I just want to look. What did I miss?
Again here.
Sir, so when the phase angle is lagging, we put the.
So, sir, 314 multiplied by E7, which is time, right? So W multiplied by time. Oh yeah. Okay. I
Of
didn't know
course.
that.
Of
Yeah.
course. It's WT. That's the general function right here.
Yes. That's it, sir.
So when the phase angle is lagging, we put.
Yes, I got the same answer now.
Okay, very good. Any other question? Is everyone okay now?
Sir, the phase angle,
Yes.
when it's lagging, we put it as 90 degrees, and when it's leading, we put it as positive 90, right?
Yes.
Okay.
Because when you put positive, remember what I showed you, like this one. See, look at this. We still use the plus sign here, but if I put 40, which is positive 40, it means it's leading. Leading means the graph goes backwards. Look when I increase this 50, it will go back further. If I go 70, it goes back even further. But if I put minus 60, it goes forward. Look at this zero crossing. It either goes back or goes forward. If it is negative, the shape of, or the shape of, or the profile, the envelope of the wave moves forward, which is lagging. Lagging means what? It happens later on.
Yes.
Leading means it happens before. So right now, this orange sine wave is happening after this blue sine wave. So it's lagging. That's why we have this minus.
But if you put it at 0, it will start from the middle.
If you put 0, it'll be exactly on top of each other. There's no phase angle difference.
Okay.
See how sensitive this one, like I put minus 10. Minus 10 becomes what?
The up, down.
It was lagging. So
Yeah.
it goes forward. See how little bit, it just moved forward a little bit.
Yeah.
If I go plus 10, it will go to the other way. Of course, if I extend this line, it's going to go here. So it's actually leading now. It's leading, it's happening before. Is that clear?
Yes.
20 will lead even more. Again, always think of extending this line to the 0. Or we can make 2 cycles, guys. So instead of these, we can make 2 cycles. So you can see it more clearly. You can see 2 zero crossings. So 8, 16, and just 17 is enough. Okay. Now instead of this, I'm just gonna delete that. And then we'll go, again, plot, insert, scatter, and then this guy. So now you can see it very clearly. Just watch these two. Obviously, the orange is leading. Now, by the way, of course, you can always make these, resize these plots, make it clearer.
But now you just use more points to make it more accurate.
You can use more points, yeah, but it's still the same thing. Like, so if I say 0, they are on top of each other. If I say minus 10, it's going to move forward, moves later. Minus 20, further on. Say minus 30. So the more minus, the more lagging. You can see the difference here or here. But if I say 30, it's going to be the other way around. It's actually leading. This orange signal is leading this blue signal. Okay?
Yeah.
So lagging means negative angle, or leading means positive angle. Okay? I've got a
So
number
I have
of,
a question
go ahead.
about the table which you made. The time, how could you basically did the setup like 0.0025 and then scroll it down until 17 points easily, like quick?
Yeah, of course. This is the beauty of Excel. What happened was I had values up to here. So what I did was I highlighted two of these cells, 2 consecutive cells, and then again lower right until the icon changes to positive plus sign, and then click and hold and drag down.
Yeah, I did this, but I didn't get the same answer. I guess in terms of calculation, you did something which made it go continuously, like adding up.
La. Show me your screen. I'll stop
Yeah,
sharing mine and you show me your screen.
Okay. Can you see my screen, sir?
Yes, I can.
Yes. Okay. Here.
No. Right now, this is not what you. No, show me the one you had this morning. Didn't you create one? This is for a single value.
This one.
Yeah, this one. So now, suppose you want to create here. Let me just annotate here for you. So now let's say you want to expand this. Just take these two, highlight them.
Okay.
Now take the lower right corner and drag down. Oh, yes, drag down. Yeah, it fills automatically. Keep going until you get to about 720. Yeah, that's it. Now just highlight the whole thing and go do your plot. Yeah, that's it.
Yeah.
No. Go to the top one.
This one.
Yeah, that's it. That's much smoother. So then you got more points.
More points.
Yep.
Okay.
That's how easy it is and how powerful this visualization tool. Okay. Any other question?
Nope.
All right. Come on, guys, you've got lots of work to do. So we've got about 7 more minutes remaining. See if you can solve those 2 questions, and then work on your plots.
Sir,
Yes, sir.
Hour after
Actually, yes, sir.
are you available after the first session?
No. I have another session for up until 4:30. Immediately after this session, I have another course.
No, I mean after the morning one, the 10:40.
At 10:40.
After the 10:40 session, do you have another session before the prayer break?
No, at 11:30. No, I don't have a class. My schedule is on D2L, Sa'adan, for everyone. In fact, I have 2 schedules on D2L. One for Ramadan timing, and the other one for after Ramadan.
Okay. So
And guys, be sure to fill in the class rules. You're all familiar with the class rules. Just fill them out as usual
already sent it.
and upload to D2L.
انا مش مسوي استاذ.
شو مسوي؟ ما فيش بعد. There'll be no grades then.
ليش؟
You have to what do you mean مش مسوي ايش؟
ما راح اسوي الكلاس رولز.
لا, you need to make the class rules. It's required for every course.
تمام استاذ. الحين لان انا متاخر ومش فاهم ولا شيء قاعد تسوونه اصلا.
طيب.
الاكسل هذا وين القاه اللي قاعد تسويه انت؟
Excel, you never use the Excel spreadsheet?
لا بس الفايل مالك هذا وين القاه؟
No, my file I didn't put it on well, but I can if you want. I don't want you to copy what I'm doing. I want you to create it from scratch. That's what I want you to look at the video, يا إبراهيم.
خلاص بشوف الفيديو الاول والثاني عشان افهم لان انا مش فاهم ولا شيء استاذ.
No, I understand. This is the problem with missing some classes. So please make sure you don't miss.
دعوة استاذ ترى اول يوم وش اسمه يعني.
I know. I have to hit the ground running because of the. But again, we're going to hit this time and time again. We recorded everything from the very beginning, and of course, if you have any questions, you can ask me or you can ask one of your peers.
So it's possible to post the spreadsheet on D2L, please. So.
Yeah, Saad, I can do it, but I want you to actually try yourself before.
Yeah.
I don't want you to copy my sheet and work with it. That's not, it's a shortcut, but you're not learning. I want you to do, because it's going to get more complicated. Let me show you what I mean. Let me show you, I don't want to alarm you, but let me show you what I have in mind. Because this is all leading to harmonics, right?
Yeah.
So with harmonics, I'm going to share my screen again. See, this is what eventually I want you to be able to create, to understand what these harmonics are all about. So here we go. See this one?
Yeah.
I mean, this we're going to discuss this. These are actually, what you see here, the blue signal is the fundamental frequency. And this is a harmonic. This is actually a third harmonic. Now,
Yes.
when the third harmonic interferes with the fundamental frequency, we get a signal that is distorted like this. And here are what we're just doing now. Here is the first signal. Here's the second signal. And this is the sum of the two. If I do this, this is just adding these two together. So if you know how to create this one, and you know how to create that one, then the composite signals are straightforward. See, there's your E3. And by the way, if you go to D2L, you will see that there's a PowerPoint that we're going to be discussing, in fact, this week. But I want you, instead of me just giving you flushing information, I'm trying to get you to be working at the same time. Okay?
Yep.
Because remember, when we will see each other again on Thursday. So I want to, what I'm coming to, Saad, is that I want to hold off to sending or giving you access to my spreadsheet, because I want you to go through the process and think about what is, because when you're thinking about creating the plots, you're also thinking about the frequency. You're thinking about the amplitude. You're thinking about the phase angle. All of these are issues that you need to be aware of for signal analysis like we're doing now. So what's Fourier analysis and Fourier transform? It's signal analysis. You can think of Fourier transform. It's like an X-ray machine of sorts. It's capable of looking at a complex signal and basically determining what frequencies are present in that complex periodic signal. It has to be periodic. So that's when we say wave spectrum. It's basically what is the frequency content of this complex periodic signal. And that's what the Fourier transform does. And the Fourier analysis. Basically, when we look at a periodic signal that is not a pure sine wave, the question is, how can we represent this complex periodic signal as a summation of pure sine waves? And that's what we're leading to. I mean, the course is mostly on this process, as you can see here.
So,
if I don't give you this blue signal and this orange signal and give you just this composite signal and ask you what are the fundamental frequencies contained in that composite signal, well, you don't know until you do some analysis. Well, that's what Fourier is. By analyzing that signal, I can tell there is this frequency and there's that frequency. In this particular example, the fundamental frequency is 60 hertz and the harmonic is 180. So that's third harmonic, 3 times 60. Does that make sense?
Yeah.
Okay, guys, work well. Maybe this is just like a puzzle, but it's a puzzle of technical implications.
Mr. Hafuda?
Yes, sir.
Could you mark me present? I came a bit late, few minutes.
Same here.
For your information, guys, Zoom keep the full record of who came, what time they came, what time they left. So if you came in very late, I will still record you as absent.
All right,
Remember
sir.
the rule. If you're 10 minutes late, I could record you as absent. So don't be late, guys, because you don't want to miss classes. You don't want to miss this discussion. It's very detailed.
All right, sir.
Okay.
Got it.
Who's this? Is this Muhammad Amin?
No, not Muhammad.
No,
I mean,
no,
Sayyid.
it's me and Hasib.
Sayyid. Okay.
And
Sayyid.
Hasib.
And Hasib.
And Hasib.
Oh, Mr. Hasib.
Mr. Harpola,
Okay. Yes, sir.
where do we upload the Excel spreadsheet?
I don't want no, I don't want the Excel spreadsheet. What I did is there is a Dropbox on D2L. You can
Okay.
just take an image. I'm not going to check your Excel spreadsheet. I'm just going to see if it is correct or not.
So a screenshot or just save the
Yeah,
image.
just a screenshot and put it on PDF and submit. But
Okay.
one PDF, guys, not multiple PDFs.
تمام.
Okay, but
So
I don't
خلصنا الحين
see
خلاص ولا؟
any additional Dropbox
That's
here.
it. Anybody wants to leave, you can leave. We're done.
تمام. أستاذ متى بتنزل الفيديو؟
Which one? The first one is already on D2L.
لا second.
This one. The
Second
lab
one is still, this one is still recording. I'm just going to stop it in a minute, and then it takes
Upload.
Yeah, then I will upload it. It will take a little bit of time.
Okay.
Or
Thank you, sir.
for the
Thank you, Mr. Muhammad.
Have a
You're
great day.
welcome. Okay, you're welcome.
Thank you.
Okay, guys. Thank you very much.
Thank you.
Okay,
Yes,
see you
sir.
then. See you on Thursday. Yes, sir.
Sir, can you send an email regarding changing the timing for Tuesday?
Is this sad?
Yes.
Sad, your voice comes in sometimes very, very weak. What did you say? Say again.
Saying, can you send an email regarding the changes on Tuesday in order to keep both
Wow.
lessons?
Well, when you see the recording, you will see how bad your
Type
voice
it in
comes
chat.
in.
Type it in chat.
How about
Yeah,
now?
yeah. What is you saying? Email. What about the email?
Can you hear me now?
Yes.
I was saying can you send an email regarding Tuesday's class, keeping the classes back to back?
Email regarding Tuesday class. What about Tuesday class?
Making the sessions back to back.
No. It's not my request. It's your request. You have to send a request or as a group. But I can tell you that this week is extremely hectic because they've got a lot of issues with scheduling. I mean, you can send an email to Mr. Permjit. I will not approach it because I already have approached it for some changes. And he's saying that they have a lot of issues that they need to sort out.
I mean, but for the meantime, we can just do it ourselves, just online. If we all then we can just do it.
No, yeah, Saad, you need to test your audio, make sure that they are working properly because we cannot communicate like this. Okay, I'm ending this meeting because I have another one in about 5 minutes. See you on Thursday.